Hi class, we're continuing on with pages C15 to C18, taking a look at the mode, and then we'll look at measures of skewness. Okay, let's take a look at number 22 here. It says find the mode of the ages of the 50 people, and that's from data set number 1. Now, incidentally, when we're going through this, we've already taken a look at the data sets before, and when we get into skewness, we will have already calculated a lot of the measures that we need, in particular the mean and the median. And so we will be kind of jumping back and forth here to pages that you've already looked at and done. So have your manual in front of you when you do this. So we're taking a look here at the mode of the 50 people, data set number 1. Now, the last place that we saw that was, let's see, back on page, let's see, looks like about page 71 here for me, which is, this is when we were talking about the median. So this was on page 9. And so we're going to use the same data here, of course, and take a look here then at the not the median of the 50 people, but the mode of the 50 people. Now, the mode is the most frequently occurring value. And so maybe just stop this tape for a minute here, this video, and take a quick look and see which one has the highest count, which number occurs most frequently. And what you'll see is that it is the number 68. And so it occurs 4 times. There's no other number that has a count of 4 or more. You could, of course, have a number like, let's say, 74. If there was 4 of them, then you would have 2 modes. You'd have a 68 and a 74. But in this case, there's only one value which has a count of 4, and that's the 68. So that is your mode. Now, most of the rest of the questions on that page actually just follow these data here. So I'm going to continue on here, and then we'll go and we'll fill in the ones that we need later. The next question will ask, what is the mode for the marks of 50 students? And so I'm taking a look on page C10 when we looked at calculating the median. And again, what we're going to do is we're going to look for the number which occurs most frequently. So maybe stop the video at this point. And what you find is that it is number 62, also with a count of 4. So that is your mode. All right, I don't think I asked you to do this next one here, but on the mode page, the next question asks, find the median of the TV ratings of the Business Admin 111 students. And so I've got a little table down here which shows you then the class marks, or the values 1 to 10, and then their frequencies. And so all we do is we go down here and find the one with the greatest frequency, and the greatest frequency is 19, and so the mode then is equal to 6. All right, and then there's one more example down here. And this one here then says, again, taking a look at the mode page, which we'll get back to and fill in the blanks, is find the mode of the eye colors. And so in this particular case then, you can take a look at this little chart here that I have on the right-hand side on page C11. And what we've got here is 30 blue-eyed people. And then we've got 28 brown-eyed people, 12 to 10 for the other ones. And so the mode then is 1 or blue-eyed. Now the question that we'll ask here is, well, can you use the mode then as a measure of centrality? And centrality is kind of a goofy word here. We'll talk about that in a second. But can we use it as a measure at all? And for nominal data, which is what we have here with eye colors, the answer is, oh, absolutely yes. And so we can find out which is the class with the highest frequency. The same up here then with the TV ratings. These are ordinal data. And so we can say that there are more 6s than any other type. So the mode can be used there. And then back up here, when we were taking a look at these type of data, the ages of the 50 people and the marks of 50 students, these are interval data. And so you can calculate a mode for those. So I'm going to go back to page, I think it was 77 here in my book. So page C15, and we're going to fill these in. So taking a look then at the ages of 50 people, what we found here then was the mode turned out to be 68 with a count of 4. There was no other value that had a count that high. Similarly, for the marks of 50 students, there was a mode of 62. It also had a count of 4. There's nothing special of the count. Oh, count of count. Let's change that to 4. Nothing special about the number 4. That's just that was the highest frequency. The mode of the TV ratings of Business Admin 111 students, and we said that that was a 6. And the count in that particular case then turned out to be 19. So remember, that was the frequency, right? The count is the same as the frequency. And then the mode for the eye colors. And what we found out was that it was 1 or blue. And we had here a count of 30 for that. And remember, a count then is the same as a frequency. So the question is the mode a good measure of centrality? And so I want to give you a couple of cons, but then also a pro here. And so the couple of cons here say, well, the problem is that you can have more than one mode. Or no mode. Or I suppose in no mode would mean that they all have the same count of 1. And so you could say all of them are modes in that particular case, but typically we would say that there's no unique mode in that case. So I gave you the example that in the ages of 50 people, we could have had, say, 4 people who had 74, in which case we'd have 2 modes. We'd have a 68 and a 74. And so you don't necessarily have just a single mode. And again, there may not be a unique mode at all. The other thing, too, is that it can occur anywhere in the data set. And so we could end up with, say, a very high mode or a very low mode. We could end up with marks on the 50 students. We could end up with 5 students getting 95. And so that is not really a good measure of centrality. However, a pro about this then is that it often is close to the mean and the median. Now, think of the examples that we took a look at. So the ages of the 50 people, the mean turned out to be, it was about 70, I think. Yeah, it was 70. And so 68 is pretty close to that. And for the marks of 50 students, the mean was 60. And so 62 is pretty close to that as well. And that's not a huge surprise because of this whole thing that we're going to get into in a bit here. And this is that data are often normally distributed. So we don't really know what that means in this particular case. I'm going to put down here bell-shaped. But what it means is that if you take a look at, say, a typical exam marks, their distribution, let's say the average was, say, 60%, what you would find is that there would be a lot of people around the average of 60%. And so, you might have a whole bunch between, say, 50 and 70. And then it starts to taper off as you get into lower marks and as you get into higher marks. And so that kind of bunching around the middle forms a kind of a bell shape, which we'll see. We call that the normal distribution. And so it's not surprising that the numbers with the greater frequencies are actually close to the middle, close to the mean, and close to the median. So that is a pro about that. Okay, next we're going to take a look here then at the mode of grouped data. Although there are fancy formulas for calculating that, we're going to use something that we just call the crude mode, which is the midpoint, or the class mark, I guess more officially, of the class with the highest frequency. So if you were to take a look at a histogram, you would find that it's the high point of the frequency polygon. Let's take a look at a couple of these. We're going to take a look at the ages of 50 people and the marks for 50 students. And it says here, find the mode for the group data. Does it differ from the mode of the ungrouped data? So the ungrouped data, what we had was just right here. So it was 68 right there. Let me go to a different color here. So it was 68 with a count of 4. And then for the marks of 50 students, it was 62. So I'm just going to put those down here and say, so we had 68 and we had 62. That was for the ungrouped data here. Now, I'm going to actually take a look here then at some Excel tables here. So let me just go over here then. And we're going to take a look then at the ages of the 50 people. And what you'll see here then is that the class with the highest frequency is this guy right here. 70 to 79 has a class frequency of 12. And so the midpoint or class mark of that is 74.5. So that then is what we would call the mode, the grouped mode. Down here, we've got the marks for 50 students. And the class with the highest frequency then is 50 to 59, with a frequency of 15. The class mark, or the midpoint of that class, is 54.5. Before we go back and write those in, let me just show you here then here's the histogram then of the ages of the 50 people, and you can see that the high point of the frequency polygon, where it comes to a point, is in the 70s, so 74.5 there. And then let's take a look then at the marks for 50 students then, and you'll see that the high point there is in the middle of the 50s, so 54.5. All right, let's go back and just write those in then. And so what we had here then is the high point of the frequency polygon was 74.5. That was in the 70 to 70s class with a frequency of 12. And then for the marks of 50 students, it was in the middle of the 50s class. I think the frequency was it 12, I think? And the midpoint there was 54.5. So that's what we've got for that. Sorry, this should have been a 62 over here. So 68 and 62. So you can see they're not too far off in terms of that. Let's continue and talk about this concept of skewness. Now with skewness, it says here, why is it that the mean and the median may differ for some variable x? And the reason is that the median is simply the physical center of the data. So if you put them all in order, then you find that middle value, or if there's an even number, then it's the middle two values, and so it would be halfway in between those two. And the mean, on the other hand, then is the arithmetic center of the data. The arithmetic average, of course, you add them all up and you divide through by n to get the arithmetic center of the data here. The problem is that they can differ because of extreme values, either very high values or very low values. So the example that I talked about in class here is Bill Gates. And so we might be looking at the average income of students from last year, and let's say it turned out to be, I guess I put a number down here, of $8,000. Now, some of you were in school, and so you didn't make any money maybe, or very few dollars in the summer, and a number of you were working full-time, and so you might have made several tens of thousands of dollars. But we bring in Bill Gates, and he makes something like $2 billion a year, and if we average that out over our 46 students, we would get something like $43 million. So that is a really high average and not really indicative of the midpoint or the center of the data, because his income pulls the average up, or it skews the data upwards. Now the median, though, as we mentioned before, is just if we were to line everybody up, person from 0 is on one side of the room, and then all the way up to Bill Gates on the far end, he's just the last guy, that's all. And so we just simply go and we find the middle person. If we've got 46 people in our class, it'd be halfway between the 23rd and 24th value. We'd ask them, what are your incomes? We'd average them, and that would be the median. And that's probably a better measure of centrality if we got Bill Gates in there. Let me demonstrate here with a couple of examples here. So number 29 here then says, calculate the mean and the median for each of the following lists of numbers here. And so what we've got here then is the mean, of course, is going to be equal to the sum of the x's over n. And so we would just simply add these up. I'm not going to actually go through that with you on that, but I do want to get to the right page here. And what we would find there is that we would end up with 50 over 5 is 10. Now, the median is also equal to 10. These numbers are all in order, and so it would be the middle number, the value of rank. What do we got? 1, 2, 3, 4, 5. 5 plus 1 divided by 2, so the third value is 10. All right, let's change colors here now. And we're going to take a look then at the next one here. And here, what I've done is I've taken this last number and just added 50 to it. So this is an outlier. It's skewing the data upwards. And if you were to sum these guys up and divide through by n, you'd end up with 100 over 20 over 5, which is equal to 20. And then the median is still equal to 10, the middle number. Then what we do then is we calculate the difference between the two. So the mean minus the median is equal to 20 minus 10 is equal to plus 10. So what we'll see is we will say that these data are positively skewed. For the one above here, we would say that the mean minus the median is equal to 10 minus 10 is equal to 0. So these data are symmetric. They are not skewed. Let's take a look at this by drawing out a couple little pictures here then. So here's a nice looking bell curve. And with a bell curve then, and you can think of this as being like a frequency polygon on a histogram. If you had a whole bunch of bars here and they're very thin, then you would have a nice smooth line that joins up their top points. Think of the bell curve as being like that. And so you've got some variable x here, and what you would find is that the mean is going to be in the middle, and it's going to be equal to the median. And by the way, it will also probably, I'm going to put this in brackets, equal the mode. So the mean, the median, and the mode are all the same here. And most importantly is that this difference here, the mean minus the median, is equal to 0. And so that means that it is not skewed. And so it is a symmetric distribution. Now, when the mean of some variable x is greater than the median, then, and think of the Bill Gates example, then what you've got is extreme values pulling the mean upwards. So the way that I'm going to draw that here is like this. So it's almost like you took the right-hand tail and you gave it a yank. And what you would find here is that you'd have, this would be the mode. I'm going to put that in brackets here. And then you'd have, most importantly, is the relationship between the mean and the median. So you've got something like that. And when you take the difference of the mean and the medians, you'll get some positive number. And so what we say then is that the data are positively skewed or skewed to the right. And then that leaves us with one more scenario, and that's where we've got this kind of thing, where you've kind of got a longer lower tail, like that. And again, I'm going to put the mode here in brackets because that doesn't actually come into the calculation. But you would have a median here and a mean here. You can see that the mean is lower than the median. And so when we take mu minus the median, we would end up with some negative value. And so we would say that the data are negatively skewed or skewed to the left. So that's the formula that we'll use for that. If you use Excel, like the data analysis tool pack, for instance, which we'll get into in labs, will give you a measure for skewness. We don't want to use that actually, and because it uses a more complex formula, and we're just not going to get into that in class. Let's take a look here at the histograms from Unit G and the marks for the 50 students here. And let me go into Excel here and see. And I'll go back actually to this one here. The ages of the 50 people, as you can see that this looks like this is negatively skewed. And so it's like we took our lower tail and gave it a yank to the left. So skewed to the left. And so what we should end up with then is a mean which is lower than the median. So let's go back here and see what we've got here. And we're going to take a look here then at the mean and the median. And we'll take a look at the mode also, calculated earlier in the unit for the group data. And so the mean turned out to be, what do we got here? The mean turned out to be 69.9, and that was back here, right there, so 69.9. So that was on page C7. That's where you found that. And then while we're here, we are going to be taking a look here at the marks of 50 students, and so that's on page C8. And I'll show you actually the Excel charts here that will help you out on that one later. So let's go back here to the page. And so the median then, we calculated also then to be, let's see, 72.5. This was page C7. This was page C13. And I'll quickly take us back there just for a moment, just to take a look at that. So remember this ugly guy here that we did? Exercise number 20 on page C13. We got 72.5 there. Oops. So the difference between those two then, the mean minus the median, will be 69.9 minus 72.5. 0.5, and that's going to give you a negative 2.6. So we would say that these data are negatively skewed, or skewed to the left. Now, it's not as important, again, to take a look at the the mode, but the mode will probably be higher than both the mean and the median. And what we ended up with here is that the grouped mode turned out to be 74.5, and that's just earlier in the lesson here today. Okay, the marks for 50 students, we're basically going to the same pages. I think it's page C8 here. We found that the mean is equal to 60.9, I think it is. 60.7. 60.7. And this is on page C8, and then the median turned out to be 60, which is on page C14, I believe. Let's take a look here, actually, at these graphs from earlier here. Graphs and the charts here. So when we did the calculation for the mean here, which was right in here, this is what we're looking at here is the ages of 50 people. Remember what we did is for each class, we took its midpoint or class mark times its frequency to get an MF value. And then we did that for each class going down here. And we add them all up, and we get 3495 divided by 50, the sum of the frequencies, and that gave us a mean of 69.9. Now, for the marks of 50 students, same sort of thing. So for the class of the 30s, we took the class mark times its frequency, gave us the MF value. And we did that for each of the classes, added them up, divided through by 50, and we end up with 60.7 as the mean there. So that's what we've got there. Yeah, so this was a 7, 60.7. So in this particular case then, we would say the mean minus the median is equal to 60.7 minus 60 is equal to positive 0.7. So you could say that these data are slightly positively skewed. Now, by the way, on an exam or on an assignment, if you said that they are slightly positively skewed, I'd say, good for you, you get full marks. If you say they're pretty close to 0, so they look like they're pretty symmetric, then that's good too. The only wrong answer would be that they're negatively skewed, because, of course, the mean minus the median gives you at least a positive number, if not 0, but it doesn't give you a negative number. It turns out actually with the ungrouped data that the mean is equal to 60, the median is equal to 60, and so 60 minus 60 turns out to be 0, and so these data are not skewed. In terms of the mode, what we've got here then is that turned out to be 54.5, which we would expect to be lower if these data were positively skewed. So that's what we've got. So I'm going to leave you with a couple of problems for homework, number 32. We'll have to use the ungrouped sales. We didn't group these guys, so take a look earlier on in the unit and find out what the mean was and the median, and then what the measure of skewness is. And then finally, we'll take this one up in class. I'd like you to fill in the table below with advantages and disadvantages of the mean, median, and mode as measures of centrality. And then we will take that up in class. So I'm going to end the lesson here.